Ixia, a leader in performance analysis solutions, presents the IX Network video tutorial series. IX Network is Ixia's flagship software application for testing the network infrastructure, including all devices like routers, switches, network access controllers, broadband access, carrier Ethernet, and data center Ethernet. It's used by professionals around the world, including development and system test engineers, network design and support engineers, and even marketing and sales to demonstrate product capabilities and performance. This video tutorial is brought to you by the IX Network Product Management Team. Hello and welcome to this IX Network video tutorial on the topic of testing service level agreements. In Chapter 1, we're going to cover the test overview, including defining what service level agreements are and how they're implemented. Next, we'll cover the objective and the test setup for this example. Then, in Chapter 2, we're going to go into the IX Network software and build traffic using the Advanced Traffic Wizard, including configuring IP precedents, enabling flow groups, and tracking based on IP precedents, as well as enabling egress tracking. Then, in Chapter 3, we're going to validate the service level agreements by going into the StatViewer and IX Network, looking at the aggregated stats, using the multi-field drill down and drilling down into the group by IP precedents. And we're going to look at enabling advanced measurements like enabling delay variation, also known as jitter. Before we get into testing service level agreements, let's define what they are. So carriers or network operators provide service level agreements to business customers, providing a guarantee of service performance. Performance criteria can include the network uptime, bandwidth parameters, loss, latency, and jitter parameters. These performance characteristics can be specified to the type of traffic like voice, video, and data in a triple play network, since they all may require specific performance. Technologies used to implement class-based services to ensure performance end-to-end include access lists to identify the traffic, features like committed access rate or CAR, which can perform rate limiting and take action if the traffic exceeds that particular rate, features like toss or IP precedence and diff serve, which can mark packets to ensure the behavior end-to-end over multiple hops for that particular performance category. Features like weighted random early detection or weighted red, and class-based weighted fair queuing, which are queuing policies which can determine how traffic is queued on the egress of an interface, as well as priority queuing. So these technologies are used for classification, coloring, policing, congestion management and avoidance, as well as shaping. So some policies define things like committed access rate, a peak rate, and a burst size as well. So in this test case, we're going to do a test where we validate the service level agreement performance. The objective is to validate the service level for triple play services for voice, video, and data. Each one has specific bandwidth, packet loss, jitter, and latency parameters. To accomplish this test, I have two ports connected through a network cloud, and we have three types of traffic as I defined. Each traffic type will be mapped to an IP precedence value. So data is IP precedence 1, video is IP precedence 4, and voice is IP precedence 5. The data will have a committed access rate of 5 megabits per second with burst, and the exceed action is to remark traffic to toss 0, making it best effort across the network. Video will have a committed access rate of 8 megabits per second with burst, but the exceed action is to drop traffic that exceeds the committed access rate with burst. For voice, the committed access rate is 1 megabit per second with burst, and the exceed action again is to drop. So the logic here is with voice and video, you don't want to remark it to where it's best effort on the network. You would rather just drop it as soon as it exceeds its policy, such that you're not delivering traffic and it's late and has high latency and loss. It's going to be discarded anyway. So once we're at a normal state with the network, we're then going to increase various traffic levels to exceed the rate and then confirm what happens, including validating that the data traffic is remarked to a toss 0 and the voice and video is dropped when it gets to a certain rate. Now, to accomplish this, we're also going to be enabling advanced measurements, including the delay variation, also known as jitter. So here in Chapter 2, we're going to go into the IX Network software and configure the test for testing SLAs. The first step is the Port Manager. In the Port Manager, you click on the Add Ports Plus icon here to add ports to use in your test. In my case, I've already added 2 ports. I'm using 2 ports on the XMV16 load module. Next is protocols in Step 2. So this particular use case is not focused on testing protocols or routing protocols, but I am testing a layer 3 network, and therefore I do need to ARP. So we're going to go into the routing and switching config, and under protocol interfaces, and I've added IPv4 interfaces on each port, and I've configured the IP addresses as you can see here and the respective gateway and enabled those interfaces, and they're currently up and you can see the status is green. So now we're ready to move on to the traffic piece. For traffic, click on the traffic view within the test configuration list, and there's 3 ways to build traffic in IX Network: the basic wizard, the advanced wizard, or using quick flow groups. For this particular use case, I want to build advanced flow groups, meaning I want to have flow groups for voice, video, and data. I want to enable advanced tracking, like tracking on the IP precedence, as well as egress tracking. And so I'm going to use the advanced traffic wizard because it exposes the most control and flexibility. So when you launch the advanced traffic wizard, the first item here you'll see is the traffic name. In this case, I'm going to rename the traffic item name just for ease of use to SLA-traffic. Next is the type of traffic I'm using is IPv4. So I don't need to change the encapsulation type. I'm staying with IPv4. Also, my route range, I'm doing a 1-to-1 mapping, and so I don't need to change that. There is an easy one checkbox for enabling bidirectional traffic. So next is I choose my source and destination, and you can see the ports here, and if I expand out this tree, you can see that on this particular port I can see my IP address of the protocol interface that I built. So I'm going to be sending from that source port to the destination port on port 2. You can see the IP address of the protocol interface on that port. So those are the source and destinations that I'm going to use for this test. And I click on the green arrow button to choose them as an endpoint set. So the Advanced Wizard allows you to build multiple endpoint sets in a test, but for this particular test case, I can accomplish what I need to with a single endpoint set. So I click Next. So here's the packet and QoS view. In this view, you can edit the packet contents. You can expand the tree, edit particular fields. Here's where you can add things like IP, UDP, or TCP on top of the existing frame. The one thing I do want to edit here is the type of service. I can edit it here down within the packet editor, or if I am on the, you have to make sure you're on the per encapsulation view. We have a new dialog box at the top here, and via this view I can click in on the TOS and I get our new TOS editor. So for this particular test I want 3 different IP precedence values. So I want values, and then for me I like to configure in decimal. So we're going to configure values of 1, 4, and 5, because we're going to be essentially emulating on the wire data at 1, video at 4, and voice at 5. So I select OK. I select Next. So here's where we allow you to configure flow groups. Enabling flow groups allows you to control the transmit characteristics, like if it's bursty or constant, and things like frame size and rate on a per flow group basis. So I want to do per flow group for voice, video, and data, and I'm assigning voice, video, and data. I'm differentiating them on the wire based on IP precedence. So I want to build my flow groups based on IP precedence. So select Next. Here's the frame setup dialog, and here's where you configure the frame setup at the traffic item level. However, I will be configuring traffic at the flow group level when I'm done with the wizard, so I can leave it at the default of 64-byte frames. Next, in the rate setup as well, once again I'm going to configure it at the flow group level after I complete the wizard at the traffic item level, so I can select next. So here's flow tracking. Flow tracking is important because from a summary level statistics, this determines how you're able to drill down. So since we're enabling voice, video, and data by IP precedence, I do need to enable tracking per IP precedence. I then also, in most cases, would be incorporating routing or have many source and unique source destination addresses. I could also enable multi-field tracking by enabling things like tracking on the destination IPs as well. Now, since my service level agreement policy for data is when I exceed the policy, and the burst for the committed rate is to remark traffic from a IP precedence value of 1 down to a 0. So if I want to validate that remarking is occurring, I need to enable egress tracking. For egress tracking, I want to track on the IP toss, the precedence bits. I select that and I select next. Here you get a packet preview. If I click on the View Flow Groups and Packets preview, it will generate those for me, and I can inspect to make sure that it's built what I think it's built. So I have 3 flow groups, and as I click on each one, I can see the appropriate precedence value has been configured, and it looks good, and so we can move on. If I did things within the packet like used increment, decrement, or list operations, you'd see all those here within the preview. Next is an optional step to perform validation. With validation, you click on the Validate button and we'll validate the configuration, the packet content, the flow groups created, and the flows to make sure you don't have any issues with what you've built against the hardware you've reserved. So I look good here, no errors, and I click Finish. So now that I've completed the Advanced Traffic Wizard, I can see here I get a graphical depiction. If I click on or float my mouse over the port, I can see my transmit port and my receive port. And then I can see the flow groups that are built here in this grid. The particular view I'm on is for this particular traffic item, which is the SLA traffic. So I do want to do some customization here, and to do that I'll just go ahead and edit within the grid. For example, I would like to edit my flow group names. So because this is representing data traffic, I'm going to rename this as data. The next flow group is representing video, so I'm going to change that to video. And the last one is representing voice. That just changes it so it makes it a little more user-friendly when I'm looking at this in the configuration. Next is, as I scroll over, I can see particular properties of this traffic. For example, the frame size and the frame rate. For my data traffic, I know the average frame size is 512, so I'm going to change the frame size, this particular flow group. Next, for the video traffic, it's bigger packets. It's going to be 1024 byte packets, and for voice is small packets, so I'm going to leave that at the minimum size of 64 bytes. Next is the frame rate. As I expand the frame rate here, I want to configure this as a layer 2 bit rate. And I know on my device I've configured committed access rate plus burst for each of these values. So for example, my data traffic is 5 meg, so I configure 5 meg here in the grid. Next is the video traffic. My layer 2 configured rate is 8 meg. And my voice traffic that I'm emulating, my committed rate is 1 meg. So now I've configured a unique frame size and frame rate per flow group, and in this case I'm doing a flow group that is applied to one port, but I could have these flow groups actually defined and applied across all my ports in a test if I was extending this and doing a larger scale test. One other thing I'd like to show you is that within this grid, sometimes it's also nice to view things like your addressing information. So we have predefined profiles for you, And one of the predefined profiles is unicast and multicast. If you click on the unicast and multicast selection, it changes your grid, adding some new tabs, including tabs for layer 2 and layer 3 information. So using the layer 2 information, I can see the destination MAC, which has been resolved via ARP. I can click on the layer 3 tab and view my source and destination addressing. So at this point, we're ready to start our traffic and validate it against the device under test. So now that I've configured the traffic, I need to apply it. I click on the apply button here. Traffic is now applied to the hardware. I can start the transmit using the green play button here. So now my traffic is started. I want to switch over to the statistics view. So here in Chapter 3, we're going to use the statistics viewer and we're going to validate the service level agreement. So the starting point in the statistics viewer for traffic is the traffic item statistic. This view gives you a summary level across all flow groups in a particular traffic item. So here I can see a stat across all my flow groups, or my voice, video, data, traffic combined. And as I scroll across here, I have no loss. I have roughly 14 meg of traffic on the wire, and I can look at my latencies, and everything looks good at this point. So another point from here is our drill down statistics. To drill down, you right click on the traffic item view and you drill down. In this case, I want to drill down per precedence because I want to view this per voice, video, and data. So that brings up a dialog, another window, and to make things a little bit simpler to view here, I am going to undock this view. Using this view undocked, I can see my precedence value 1 of data. As I scroll across here, I have 5 megabit of data coming in. IP precedence value 4, I have approximately 8 meg of video traffic, and for IP precedence 5, I have 1 meg of voice on the wire. And once again, I can scroll across and see my latency values for each of them, and looking pretty normal. I will have slightly different, I expect to see slightly different latency values because I am using different frame sizes. Larger frame sizes like video will incur actually larger delays, so that is expected to see there, but it still looks pretty good. So now I want to go back and change rate on the fly and modify my transmit properties to exceed policy. So I go back to the test configuration view. So in this test configuration view, I have chosen to click this button here, which actually hides my graphical view. And now I can do things like change rate on the fly to examine the results. So I want to change rate from 5 meg. I'm going to scroll over a little here so you can see the whole dialog. I'm going to change rate from 5 meg up to, let's more than double it, up to 12 meg. We say OK. So I can see here that my change has occurred on the fly. As I scroll across, I see I have about 12 meg of data. And once again, I see no loss. So if you remember, my policy on data traffic when I exceed my committed rate and burst was not to drop, but was to remark. I want to do another drill down here, so I right click, and let me bring this window up a bit. I right click and I'm going to drill down per the ingress view. So this gives me a view to see here that for precedence value of 1, I'm receiving traffic marked as 1, and I'm also receiving traffic marked as 0. So my policy is working, and traffic is being remarked from a 1 to a 0. If I scroll across, I can see my receive rate is right at the 5 meg of committed access is coming across as 1. Everything beyond that, so almost 7 meg of traffic, is being remarked to a 0. So I can confirm that my policy is working correctly there. Next, I want to change traffic of my video. So let's go ahead and make a jump up from 8 meg up to 15 meg. I click OK. So as I look at my statistics here and I scroll across, I do have 15 meg making it through, so I'm probably within burst. Now I'm starting to see loss, so I've exceeded my burst, and sure enough I do have loss as well as traffic coming through marked at a toss value of 4. So as I scroll over, I can see that being at 15 meg, I'm basically getting about 8 meg through, the rest is being dropped. So I can confirm my receive rate. So that looks good. But let's go ahead and bring it back down in this test to 9 meg and say OK. So now I'm just 1 meg over my committed access rate. And I can see here my receive rate is still at 8 meg. And if I scroll over, my frame delta, or my percentage of loss, is still increasing. So I'm continuing to lose traffic. So basically I do have a little bit of a burst window, but if I have consistent traffic like I have here, which is true to how video would be on the wire, I am over my committed rate and I will be dropping traffic. So let's look at the last one here. Let's take my 1 meg of voice traffic and change it to 2 meg. So I'm doubling the amount of voice on the wire. And as I scroll across, I can see my receive rate is 2 meg, but I am once again within the burst, and then I was shaped down back to 1 meg. So you can see here that once you get beyond a certain policy, in this case I was on from 1 meg. For a short period of time I did allow all the way up to 2 meg. That was my burst. Basically allows me to double traffic. And now I'm consistently dropping frames, and traffic is being shaped or down to the committed access rate of 1 meg. So everything looks good here, and I'm able to validate my policies are working correctly. So as you see here, I'm looking at receive rate and loss and latency all in one view, but there's something missing here because one of the things I'm concerned about with voice and video is jitter. So let me go ahead and close this results view, and I'm going to re-window my view here so you can have a little bit better view of the application. And I'm going to stop traffic for now. One of the new things provided or introduced in IX Network 540 is the ability to select the statistics you'd like to see in the test, as well as we've added a number of new statistics. To enable those statistics, under Traffic, select the Options view. In the Options view, you'll first go to the Global Settings view, and then the second tab here is the Statistics Configuration. So here in the Statistics Configuration, you can see the default statistic enabled is a category called latency. In this stat view, I can look down and see all the statistics I'm going to get, which includes all my receive rate information. So in the case that I was testing rate shaping, or basically rate limiting for those particular values, I can see and validate those rates we're receiving, and I can look at loss and latency in real time. But for things like voice and video, I'm also interested in testing the delay variation, also known as the jitter. So for that particular test, I'm going to disable this view and enable another view. But you can see here there's multiple views you can enable. In this case, I'm going to enable latency with delay variation. By enabling latency and delay variation, I once again select my latency mode. So we have added two new modes here. We've added the MEF defined frame delay, which is defined as first in, last out, as well as forwarding delay. So both those new measurements are available, and the latency mode will determine how the jitter is measured as well. For this particular dot, it is store and forward, so I'm going to leave it in store and forward mode. And you can see the lower selection box says, do I want delay variation with sequence errors and receive rate, or do I want delay variation with latency, average, min, max, or delay variation with latency, min, max, and receive rate? So I have different options, and as I click through them, I can see what particular values I get. For example, in this view I get sequence errors and receive rate. In this view I get the delay variation with latency, min, average, and max. And for this particular test, that's what I'd like to get. I want to see the whole characterization of the delay, which is the min, average, and max, as well as the min, average, and max delay variation. So that's how I can enable this view. This will give us in real-time loss, latency, delay variation, all in one test view. By making that change to the measurements, I apply that change. And now I change back over to my traffic view and I start traffic. Now I switch back over to the statistics view and I can start at the traffic item level. So here at the traffic item level, I can once again scroll across and look at my aggregate, and I can still see I'm losing traffic, I'm losing packets, so I can find out which group I'm losing traffic on by right-clicking and drilling down to the IP precedence level. And now I can see here I am still losing frames on my voice and video because I'm over the committed access rate. I'm just going to change my view here back to test configuration, and I'm going to go back down within my thresholds here. So for the data rate, I want to be back at 5 meg. For my video rate, I'm going to configure 8 meg. And for my voice rate, I'm going to configure 1 meg. So now I should see my frame deltas essentially be stopped, or I should stop losing traffic. And now that I've stopped losing traffic, I want to go ahead and clear out my counters. So I'm just going to hit clear statistics. So now I've cleared out my stats and I have voice video data at a normal scenario here where I'm not losing any frames. And I can scroll across and see my average delay variation, which varies from 40, right around 40 millisecond, which is okay. And my max is up at 115 up to 120 or 30 microseconds, which is once again, that's okay. And I can scroll across to my delay, and once again I'm still within my delay, because keep in mind these are in nanosecond, so when I'm in the tens of thousands, I'm in the microsecond category. I'm not even hitting 1 millisecond here. So overall things look pretty good. But this is how you can enable measurements, and you can test and validate voice, video, and data, and measure loss, latency, and jitter by enabling new statistics. So this concludes this IX Network video tutorial on the topic of testing service level agreements. For more information on IX Network, check out www.ixiacom.com. Thank you for your time and interest from the IX Network Product Management team.